Yesterday when we were talking about the natural history of a typical viral infection, I was going to make the point that it's always a race between the microbe and the host, and the host immune response. And so when you get invaded by, let's say, just one virus, it infects the cell, and then it starts to replicate, and it replicates to let's say 1,000 copies per cell. And then they get released, and then they infect 1,000 cells, and it just builds from there. But if you get a big dose in the beginning, for whatever reason, say you're a doctor in the emergency room, and you're bombarded by viruses all day long. So you get a big dose of virus, and therefore that puts a distinct advantage to the microbe. Because now what the microbe wants to do is to multiply and infect as many cells as it possibly can in your body. And it's always a race between the microbe then and the immune response. And it always takes the immune response anywhere from 7 to 10 to 14 days to really get itself revved up and going. And that accounts then for the incubation period, when the virus is basically replicating unhindered. And it's not then until you start to have the battle is engaged between the immune system and the microbe that you start to have symptoms. And one of the first symptoms is fever. And the fever, we know now, is due to the release of one of the cytokines. Is called, the initial cytokine is called Interleukin 1. But there are others. Tumor necrosis factor is one of them, and interleukin 6 is another one that I talked about. And all three of those cytokines are sort of subclassified as so-called pro-inflammatory cytokines, because those are the ones that cause the fever. They cause all of the other cardinal signs of inflammation, of red hot, swollen, and sore. And that's when you know that there's something wrong in the body. So that really accounts for the history of this particular virus. And what makes, as I said yesterday, or as I said, what makes the difference is, or makes for contagiousness is all that time before the immune system kicks in. You could be shedding virus to all kinds of susceptible people.
Right, and not knowing it.
So, and that's, and not knowing it. And so, and that sort of gets to the other point that we talked about, or when you asked me about whether there's anything you can do.
Yeah, to boost your immune system. Boost
up your immune system before you get invaded by these crazy microbes. And the short answer to that question is, right now, in 2020, the answer to that question is no. But we've been at it for quite some time. The first person who really started it, so it goes back into the history of immunology.
Okay.
And also gets into what I'm writing in my next book about at this time, which is a memoir of my time in the trenches of the scientific community, because it goes back to the 1890s when science first discovered that there were microbes out there, and that microbes could cause infectious diseases, contagious diseases. And there was an investigator in New York City who's from my hospital, New York Hospital in New York, who decided that because of the fact that he had some of his patients and some other patients had been reported in the literature to have cancers and large tumors protruding from their body in various places, and that if they sort of happened to get a very serious infection, not always, but often enough, the tumors would just melt away. And that was the beginning of the idea that the host, the immune response, the immune system might be able to do something to counteract cancer. And on the basis of that, this fellow, his name was William Coley,
right.
he decided to try to induce that kind of an anti-tumor response by injecting patients, his own patients, with first live bacteria, and then when he lost a couple of the patients due to the infections, he then decided to kill the bacteria. So he sort of autoclaved the bacteria and put the products back into people, and he had some successes, and on the basis of that, he proceeded forward. It didn't work all the time; it only worked some of the time. But all of the time, what happened is that this kind of thing of injecting people with bacterial products and so forth was very toxic, and the toxic symptoms that people got were high fever and shaking chills and generalized terrible muscle aches and pains all over their bodies. And ultimately, they could go into to have a drop in their blood pressure, and so they could go into shock. And he lost some of the patients that he injected with his preparations due to that. Well, that was 1893 when he first published that, and then in the early 1900s, some investigators from Nice on the Riviera in France were studying these different substances secreted by sea animals, and they were injecting these into guinea pigs and so forth. And they found, not all the time, but often when they found it, if they repeatedly injected the same thing into the person or the animal, that the same kinds of symptoms that I just talked about would happen in these animals, and they would go into shock and they would even die. And that was the first really notice that you could develop or you could produce allergy and an allergic reaction and what they called anaphylactic shock, and right. You could die from this. And so that put a big damper on people trying to boost the immune system.
What kind of animals were they using from the sea to inject these other creatures?
Things like Portuguese men of war and all these things that had nasty toxins.
Right.
And so they were studying that, and that's how they came on it. That was in 1902, I think. And then the other people in the States and so forth were doing similar kinds of things, and they didn't produce this anaphylactic allergic shock, but they did. What happened was they noticed that when they continually injected animals with these kinds of things, sometimes that they would get an adverse reaction, and which they called a hypersensitivity reaction. And then as time went on, in the early 1905, 1910, there were two pediatricians in Vienna that were using horse sera that was hyperimmune sera, taken really usually from horses, to treat children with diphtheria and scarlet fever. And the good news was that this hyperimmune horse serum actually worked, and they could save children from death from diphtheria and so forth. But then what happened was they were injecting not large amounts of serum, because most of the time these poor kids were little babies.
Right.
So you couldn't inject a lot of it into them, but enough so that a week or two later, after they got better from their diphtheria, they started having a weird hypersensitivity syndrome, so that they had high fevers and so forth. Their kidneys stopped working very well. And that phenomenon started to be called serum sickness on the basis of that. And that was really the end of immunotherapy as we knew it at that time, at the beginning of the 20th century. And so it's taken 100 years now for time to go by on the one hand, and more data to be, and more understanding about how the immune system works.
Right.
And part of that whole thing was the discovery that there are these molecules called cytokines. And as I described, those cytokines are actually responsible, particularly the pro-inflammatory cytokines, for a lot of the symptoms of when you try to boost the immune response, and you get what we we call adverse symptoms. So it was that way until the 1980s, and then the end of the 1990s and into the 2000s now, that once the cytokines were discovered, a lot of the different cytokines were injected into cancer patients to see if their cancer would get better. And one of the first injected, I think the first injected, was Interleukin 2, which I discovered the molecule and also its receptor. So, and there was an investigator that's at the NIH, at the National Cancer Institute of Bethesda, that started using very, very high doses of Interleukin 2 to treat his patients that had malignant melanoma and also renal cell, kidney cell cancer. And like Coley 100 years previously, he got some results, and about, it started off there was 15 to 20% responders, but as time went on and he injected more and more patients, the responders essentially came down to about 5%. So that meant that 1 out of 20 patients would get a beneficial response, and usually that beneficial response was a disappearance of the tumor, which was not trivial. Yeah, because usually 100% would die. But the only problem was that just like Coley and what they called Coley's toxins back in the early days, Rosenberg's high dose. This fellow's name was Stephen Rosenberg, and his high dose IL-2 therapy caused severe toxicity in all the patients. They got high fevers, their blood pressures went down, and he tried to support the blood pressure with infusions of more and more saline and so forth, and so that they became overloaded with water. Their lungs would fill up with water. They'd go into pulmonary edema. They had to be treated in the intensive care unit, and so forth. But as a consequence of that, and a consequence of all of the things that we've learned subsequently, immunotherapy for cancer has evolved so that we have new and better ways to try to boost up the immune system.
So it's not quite such a disparity between the risk and the reward.
Well, right, but there's still a big risk. And so if you're going to die from cancer and you're the patient, you'll take that risk. Yeah. But if you're a normal person wandering around just trying to protect yourself from the environment,
I'd rather not get infected with anything that I wouldn't otherwise.
Coronavirus, for example.
Exactly.
So I think what's going to happen now, as time goes on, I don't know how long it's going to take, but ultimately we will get new therapies, new drugs, new molecules that will do the same thing, and they'll be able to separate the severe toxicity from the beneficial effect. And you might be able to, take a pill a week or take a pill a day or something like that to make your immune system sort of on hyper alert, but not enough so that it destroys everything else. Yeah. So that's the long answer to the question.
Okay.
And I truly believe that that's going to happen. I mean, the other thing about the history of immunology is that back in the early 20th century, allergy and autoimmune phenomenon were discovered. Most of the therapy that has been used by the clinicians, by the doctors, has been to suppress the immune response. And after Coley's toxins and after Coley did his work, for the next 100 years, essentially, nobody tried to boost up the immune system. And so we're still in the early days. Maybe we've been going on for, 30 years of it, using these toxicities or using the therapies to treat bad diseases like cancer. But I think as time goes on, we're going to be able to do that better and better and better and better. It's like everything else in medicine. And as I've told my students at one stage, anything's possible in science, but some things take a very, very long time. So you have to be patient.
You need willing subjects and a long enough timeline, but you could figure it out. Yeah.
Yeah.